So let me start problem number 1. So problem number 1 is, let me check. Okay, it is recorded. So a college conducts exams in mathematics, physics, and chemistry. The probability of getting X grade for a randomly chosen student student in mathematics, physics, and chemistry are 1/5, 1/4, and 1/3 respectively. Find the probability that he or she will get at least one X grade. Okay. So the and so one assumption is that assume that outcome of the exam for mathematics, physics, and chemistry are independent of each other. Okay. Yeah. Then what is the probability? So this is the problem. So it is asked that here it was given that if I choose a randomly a student, and the probability of getting X grade for a randomly chosen in mathematics, physics and chemistry, okay, are respectively 1 by 5, 1 by 4, and 1 by 3. Then what is the probability that if I choose a randomly student, he or she will get at least one X grade? And here the inbuilt assumption is that the outcomes of the exams for mathematics, physics and chemistry are independent. So let me solve the problem. So first, let A denotes getting X grade in mathematics. B denotes getting X grade in physics. C getting X grade in chemistry. And it is provided that probability of getting X grade in mathematics is 1 by 5. So P of A, probability of happening event A is 1/5, and probability of event B is 1/4. And similarly, the probability of event C is what? 1/3, right? Probability of getting X grade is 1/3. Excuse me. So now we have to calculate the probability that at least one X grade, at least that if I choose a student randomly, then he or she will get at least one X grade. That means either A happens, or either B happens, or either C happens, or if that student is very unlucky, then maybe 3 of them happens both simultaneously, or A or B both happens, so B or C happens. So all together both all the possible things can happen. So if I represent it, say theoretically through a Venn diagram, then it may look like, suppose A is the events A, B and C. A are those those unfortunate students who get X in mathematics, similarly B physics, and similarly C is the in chemistry. So we have to calculate at least one. That means either that student remain in this region, or either these or these. So that means if I calculate what is the union of happening even union of these 3 things, then actually we'll get the probability. And then we can surely say that at least the probability we can calculate easily, that at least in one subject that individual get X. So that means we have to calculate P A union P union C. Now we can calculate it in different ways. So let me first calculate by using the summation rule of this probability. So probability A union B union C means probability of A plus probability of A plus probability of B probability of C. Let me see the formula. So, or we can calculate here also for formula. So let calculate it here. So probability A union B union C. First consider these two another event if suppose. So P A union F will be P A plus PF minus P A intersection F. PA plus PF means P of B union C minus P of A union P A intersection B union C. So P of A plus this we can write P of B plus P of C minus P of B intersection C, and these can be written as P of A P of A intersection B union A intersection C. So P of A plus P of B plus P of C minus P of B intersection C minus of P A intersection P. So now I am applying the addition rule of 2 in these two events. So P of A minus P of A C plus P of A intersection B intersection A intersection C. So now we'll get P of A plus P of B plus P of C minus P of B intersection C, sorry, minus P of A intersection B minus of P A intersection C, plus, since in these intersection A intersection B intersection A intersection C means P A intersection B intersection C. So this is the formula. So since all the events are mutually exclusive or independent, and we know from the rule of independency, P of A intersection B we can write PA into PB. Only PA intersection C we can write PA PC. So these are and another things P of A intersection B intersection C, we can write it as PA PB PC, right? And these three we get from the independency of events A B C, because it is provided that A B C are, since here assuming that the outcomes of the exams mathematics, physics and chemistry are independent of each other, so we can use the independency axiom. What is the definition of independence? So from the definition we will get these three things. So now we can easily calculate what is the P. Now we know what is the value of PA. The value of PA is 1 by 5. So write it 1 by 5 plus what is the value of P of B? 1 by 4. 1 by 4 plus P of C, that is 1 by 3, then minus P B intersection C, and here only another things. So P B intersection C will be similarly PB into PC. So minus P intersection B intersection C, so P of B into P of C, so 1 by 4 1 3 minus what is minus of A intersection B. So A intersection B means 1 by 5 into 1 by 4 minus A intersection C, so 1 by 5 1/3, right? Okay, plus A intersection B intersection C, that will be 1/5 1/4 1/3. So then it will be 5 into 4 into 3, so 4 into 3 12 here, plus 4 15, plus 3 20, minus 4 into 3 5, 5 into 4 3, 5 into 3 minus 4, here it will be plus 1. So what it is, let me calculate it. Uh, 12 plus 15 plus 20 minus 5 minus 3 sorry 12 plus 15 12 plus 15 let me do it here. 12 plus 15 27, 47 47 minus 5 means 42, 42 minus 3 means 39, 39 minus 4 means 35, 35 plus 1 means 36 by 5 into 4 into 3, so this will be 3 by 5, right? It is 3 by 5. And there is another way, so we have to do this amount of tedious calculation that, after that we get actually result, but we can use another method from where we can easily calculate the same result. So let me do in that way also. So now it is another way, so we want to avoid these tedious calculations and want to do the same thing. So we will use another PA union P union C. You have to calculate it, and we know what this means. This means 1 minus of P A union B union C, its complement. So if I from the probabilities rule, we know that P of A union B union C means this. Now from De Morgan's law, we can write these P of A complement B, A complement intersection B complement intersection C complement. From these to these we use De Morgan's law. Now since we know A, B, C are independent event, that's why its complements also be independent. So let's 1 minus, that means P of A complement into P of B complement into P of C complement. So that will be 1 minus PA into 1 minus PB into 1 minus PC. So 1 minus, let me write here, 1 minus PA. What is the value of PA? 1/5 into 1 minus of 1/4 into 1 minus of 1/3. 1 minus 4 by 5 into 3 by 4 into 2 by 3. So that will be 5 into 4 into 3. So 5 into 4 into 3 minus 4 into 3 into 2. So this will be 30 minus 5, no, this will be 60, right? 560 minus 8 24, right? 24 by 5 into 4 into 3. So again it is 36 by 5 into 4 into 3, so it will be 12. It is nothing but 3 by 6. So this is 3 by 5. So that's it. So that is the solution of the first question. Now let's move toward the second question. Question number 2. So consider a trinary communication channel as described below. So suppose that trinary communication channel, suppose that this is R1. So the meaning of this, if you want to pass a signal from T1, here suppose that you want to pass a signal from T1, and if you pass the signal in the receiver end, T1, what is the probability if you pass a signal in the T1 end, what is the probability that the individuals who is there in the other side, in the receiver side, gets the same signal, that is R1 receiver side, this is receiver side 2, this is receiver side 3. So suppose that there are 3 kind of signals are there, one is T1, one is T2, one is T3, and what is the probability that if you send a signal T1 in the receiver side, it also get the signal T1, the probability of that is, okay, that is no, yeah, so probability of that is, let me first draw the picture, then I will, there is another thing, and it can also get there. So similarly it also go there, it also go there, it also go there, and it also go there. So here the problem is the following, that so here if I pictorially show you what is the statement of the problem. So let me state the problem first. So for I equal to 1, 2, 3, Ti denotes the events that the digit I is transmitted and Ri denotes the event that the digit I is received. Let P probability that if I transmit the T1, I will get the same signal with probability 1 minus alpha, and the probability of getting a signal corresponding to T2, that is R2, is alpha by 2, and similarly P of R3, that T1 I am sending the signal T1 and the other individual is getting signal R3, is probability 2, and similarly P of R2 T2 is 1 minus beta. And what is the probability of getting wrong signal? That means I am sending T2 and that individual is getting R1 is beta by 2, and also 3 T2 that is also beta by 2. Excuse me. And similarly R3 also is 1 minus gamma. Probability of R1 T3 is gamma by 2. Probability of R2 T3 is gamma by 2. Now this means this means if I show you pictorially, then it will, suppose that I am drawing the corresponding for T1, that I am sending a signal corresponding to T1 and I am getting the right signal. What is the probability of that? Probability of getting lost, means getting wrong signal, is alpha by 2. So remaining probability, that 1 minus alpha, will be getting right probability. That is the thing. So here we have to calculate assuming assume that A3, that means T3, is transmitted 2 times more frequently than A1 and 2, more than 3 is transmitted 2 times more frequently than 1 and 2. Acha, okay, sorry, it's 2 times 3 is transmitted 2 times more frequently than 1, and 2 is transmitted thrice as often as 1. So if A1 has been received, what is the probability? What is the probability that 1 was sent? 1 was sent. Okay, so it's a very big problem. So okay, so at first, from the statement that assuming the 3 is transmitted 2 times more frequently than 1, so from and 2 is more frequently thrice often 1, so let's say the probability of 1 is transmitted is PT1, and 2 is transmitted is PT1, PT2 and PT3. So according to the problem, it says the 3 is transmitted 2 times more frequently than A. Okay, so that means P 3 is transmitted 2 times. So P T3 is 2 times more than 1, so 2 T1 and 2 PT2 is 3 T1. Since if I since suppose that one signal has been sent, so the probability, so this is the 3 signals are the whole space of the probability. We know the what is the and these 3 signals are mutually inclusive, mutually exclusive signal. So we know that what is the whole space, that is T1 union T2 union T3, that will be 1. That means probability of T1 plus probability of T2 and probability of T3 is 1. That means we write from this step to this step, because only one signal has been sent, and there are no event is such that the both signal simultaneously said T1 or T2. That means these threes are mutually exclusive independent event. So that's why we from their union we can write only in this form, because their intersection also are 0. So this is means, so PT1 plus 2 plus 3T1, PT2 means 3 PT1 and PT3 means 2 PT1 is 1. So that means 6 PT1 is 1 and PT1 means 1/6. So now we can get PT2, which is 3 PT1, only PT1, which is half, and yeah, okay. PT3 is 2 PT1. Yeah, 1/3, right? 2 into 1/6, 1/3. Thank you. So now what we have to calculate? We have to calculate that if 1 has been received, what is the probability that 1 was sent? So that means it is provided that we have to calculate this probability. 1 has been received, that means we know what, that 1 has been received, that means R event already occurred. What is the probability that R is occurred only for T1? So we have to calculate this probability, that we suppose that randomly, suppose in the sender in this T1 terminal, T terminal, transmission terminal, one of these signal has been sent randomly. Now you don't know which T1, which among the T1, T2, T3 has been sent. You only know that I get a signal R1. Now since this signal you can get from T2 also, T3 also, and T1 also. Now we have to calculate what is the probability that R, if you get signal R1, what is the probability that it is came means it came from the T1. So we use here Bayes theorem. That means what is the probability that if I transmitted a signal through a channel T1 and get R1 into P of T1 divided by what is the probability that I am getting a signal R1, right? So this is P R T1 P T1, and this is from the totality rule of the probability. We know that we can write PR1 as PR T1 T1 plus PR2 T2 PT2 plus PR3 T3 T3. And what is these things? PR1 T1. What is the probability that if I transmit a T1 and get R1, that probability is 1 minus alpha? So we know that 1 minus alpha, that probability is already given. So this is this is 1 minus alpha, right? So this is nothing but 1 minus alpha. And what is the probability that oh sorry, so this is R1. What is the probability I give T2 and getting R2? What is the probability I give T3 and getting R1? So we have to know R1 T2, it is beta by 2. So I'm getting wrong signal from T to N, so beta by 2, and PR1 T3, it is gamma by 3. Don't worry, these probability I am, since in the problem it is already given what is these things. From here I am writing this probability. Now our job is to calculate the PR1, and we know that PR1 means these summations. So this summation means again let me write it again here, PT1 T2 plus this is R1 T3 P, this is 1 minus alpha, and we have already calculated the value of PT1. PT1 is 1 by 6, so this is 1 by 6. This is beta by 2, and PT2 is half. PT2 is half, and this is gamma by 2. And what is the value of PT3? PT3 is 1/3. So this is 6, 1 minus alpha, sorry, this is thing 12 will be right, 12. So this is will be 2 into 1 minus alpha plus 3 beta plus 2 gamma. Okay, and what is similarly, what is this value? PR1 T1 into PT1, that is, so then let me write this PT1 R1. That means what is the probability, reverse probability, that I get R1? What is the probability? It came from the T1. So we have to know that the this formula will put the all value here. So PT1, we know that PT1 means 1/6. We have already calculated that here, that PT1 P21 is 1/6 into 1 minus into what, PT1 R1. So this is 1 minus alpha by this PR1. So we have already calculated the PR1. What is the value of PR1? This okay, what is the value of this? So this means 2 into 1 minus alpha plus 3 beta plus 2 gamma by 12. So that is nothing but 2 into 1 minus alpha, 1 minus alpha plus 3 beta plus 2 gamma. So that is it. So that is its answer. That is the probability that although I am giving signal from T1 with probability 1 minus alpha, with probability 1/6, and then what is the probability that I am getting a signal in R1, that is right signal, that probability is 2 into 1 minus alpha by 2 into 1 minus alpha plus 3 beta plus 2 gamma. So that's it. So now let's move over to the second question. The second question is same, and the similar structure, the question structure is similar. In this same thing, it is asked that find the, okay, now here I want in the same problem, what is the probability of transmission error we have to calculate that. What does a transmission error means? Transmission error means nothing but that I am giving a signal from this T1 end, but the receiver received the signal from either R2 or R3. So these are the error. So now we have to calculate the transmission error. So what is the transmission error? So that means what is the, suppose that E denotes the transmission error. Then the probability of transmission error is, so probability of E is that if I give T1 but we get error, and PT1 plus we give T2 but we get signal either in T3 or T1, so PT2 and P error P3. So let me here draw the things that will be clear it out. So error means either here, if I keep T1, either here or here comes. So these two things both is error. So E means for T1, E actually means either R2 or R3 happens. So then what is the probability of E given T1? That is actually alpha by 2 and alpha by 2. This is nothing but P of getting R2 T1 or P of getting R3 T1. So I am giving in T1 but I am not getting in R1. So that is the error. So that is the error, only two things, P R2 plus T1. So this is alpha by 2 and alpha by 2. From the problem we know that this is alpha, right? Let me check. P R T1 R1 alpha by 2, R3 alpha by 2. So here this is alpha by 2 plus alpha by 2, this is alpha. So similarly PET2, if similarly T2 here the error is either here signal is going or here signal is going, and this is beta by 2 and beta by 2, and this is beta. Similarly that means, okay, let me write it here also for the convenience. P of R1 T2 plus P of R3 T2. So this is beta by 2 plus beta by 2, that is beta, and P of error T3, that is 3 means either here is going or here is going, this means 2 or 3. So T3 probability of R1 T3, probability of R2 given T3. So this is gamma by 2 plus gamma by 2, this is gamma. Now put it here, let's put it here. So this is alpha into 1/6, alpha into 1/6, because we have already calculated that PT1 is 1/6 plus beta, because these things we have now calculated is beta, and PT2 is half, and this is T3E is gamma, and PT3 is 1/3. So that means 6 alpha plus 3 beta plus 2 gamma. So that is its answer. Okay, now let's move toward the question number 4. Here, let a function f that maps R to R P a function which one of the following is not a CDF cumulative distribution function of a random variable x. Okay, options are following: A, if x is 0, x less than 0, and x is greater than equal to 0, 1. P is fx equal to 0 when x less than 0, and 1 x greater than 0. C, if x is 1 over pi tan inverse of x plus pi by 2 is minus infinity less than x, and D is fx 0, 1 minus c to the power 2x x less than equal to 0, greater than 0. So we have to choose that answer which is not a cumulative distribution function, right? So let first write here what is the property of the cumulative functions. So there are 4 properties. So first property is limit x tends to minus infinity, cumulative function so 0. Number 2 property is limit x tends to plus infinity, f of x equal to 1. Third is x, that is monotonically increasing function, x less than x2, then f of x1 should be less than equal to f of x2. And fourth property is limit h tends to 0, f of x plus h equal to f of x. So these properties. So let me first check the first one, and you will see that since for x tends to infinity, that means x tends to plus infinity remain in this region, x greater than equal to 0, and you will see that is not, if I put x equal to x tends to infinity, these fx will be infinity, that is not 1. The second property of this first distribution is not following, so that means this is not a CDF. So we get our answer, A is not a CDF. Let's check the another others, all others things, that for fx, yes, if x tends to minus infinity, first word is if x tends to minus infinity, right, let me write here, so let me write here properly. So the first, the function fx, which is 0 when x less than 0, that means first things is first property, that x limit x tends to infinity will be 0, that is satisfied. But since it is x greater than equal to 0, so for limit x tends to infinity, this is not 1. So limit x tends to infinity, fx does not equal to 1. First. Second, the function fx equal to 0 or 1, less than 0, x greater than equal to 0. So here the all properties are satisfied. All properties are satisfied, that means this property is satisfied, right? So the first property is satisfied, x tends to minus infinity 0, x tends to plus infinity is 1, and if x1 less than x2, that means if x1 less than x2, so this function is look like these, right? So you can see it here, that as if x plus first if x1 less than x2, suppose in anywhere if x1 less than x2, then if x1 either equal or less than, so here and here both two region it is it is satisfied, and here also the that thing is 3 is satisfied. And last, limit h tends to 0, if x plus h is fx, so that is also true. So that means this is also CDF. Now remaining is this function c. So here from c, let c from here also, okay, fx. So if we integrate the whole function, okay, sorry, not integration. So if I put limit x tends to infinity, so x tends to minus infinity, let me do it here, limit x tends to minus infinity, 1 by pi tan inverse of x plus pi by 2. So this will be, acha, okay, sorry, limit tan inverse of x pi by 2. So if I put it there, 1 into pi by 2 minus infinity minus pi by 2 plus pi by 2, so this is 0. So first is satisfied. Second, limit x tends to plus infinity, 1 by pi tan inverse of x plus pi by 2, so that is 1 by pi into pi by 2 plus pi by 2, so that is 1. So both two conditions satisfied, and also these two also, since tan inverse x is a monotonically increasing function, so that's why third function is also true, and since it is a continuous function, so it will write continuous function. So limit h tends to 0, fx plus h equal to fx, so that also true. And the last thing is let me check here. So here x less than 0 is 0, right? If no, so the limit of x tends to minus infinity of fx of this function is 0 because this is 0. Now for x, let me for limit x tends to infinity 1 minus e to the power minus 2x, what it will be? It will be 1. So that 2 is true, and it is also a in monotonically increasing function. So that means that thing is also true. For greater the x greater than 0 is a monotonically increasing function. So that means the third property also true, and fourth is also true. So that's why the only option A is not a cumulative distribution function, but all the other functions are cumulative distribution functions. So here our answer is A. So that's it. Let's move towards the question number 5. Okay, question number 5 is an exam paper contains 5 questions, and the probability that Alex will solve that Alex will solve a problem correctly is 3 by 5, assuming he attempts each problem independently. What is the probability that he solves at least one problem correctly out of 5 problems. Okay. So here the question is, an exam paper contains 5 questions, and the probability that Alex will solve a problem correctly is 3 by 5. Okay, assuming that he attempts each problem independently, what is the probability that he solves at least one problem correctly, right? So suppose that A is he solves at least one problem out of 5. Then AC denotes he solves no problem. So the the required required probability is equal to PA equal to 1 minus P of A complement, and 1 minus PA complement, right? So yeah, now this is the thing of like a toss of a coin. So he either crack the problem or cannot solve the problem. So an exam, the 5 questions and the probability that Alex will solve a problem correctly is 3/5. So how many times, since the all problems are independent, so he have to simultaneously have to solve, he means that what is the probability that that 5 question he can, means he can't solve the 5 question all simultaneously. That is, since the all solving of a single questions are independent even of each other, that means it is nothing but the 1 minus 3/5 to the power 5, because from the independency we know that uh, the the probability of the intersection of the all independent events is multiplication. So here he has to means he will, means actually that Alex can't solve, means Alex cannot solve correctly 5 questions simultaneously. That's why 1 minus 3 by to the power 5. So that is it. So 1 minus, so this is 2/5 to the power 5. So if you calculate it, you will get 0.9898. So that is the probability that Alex solves at least one problem correctly out of 5. So that's it. Now let's move toward the next question. Question number 6, that is, let A and B be two independent events with 0 PA less than 1 and 0 PB less than 1, which one of the following is not a correct statements. The statements are following: A, that A and B complement are independent P, A complement and P are independent C, A complement and B complement are independent, and D, A and A complement are independent. So we given that A and B are two independent events. what does it mean? It means PA intersection B is PA into PB. Now let's check. So A or BC are independent or not. So P, if A and B complement are independent of each other, then PA complement B, PA intersection B complement should be PA into PB complement. So let's check it. PA complement. Okay, and B means 1 minus B, or rather, so let's not 1, it is actually B complement means actually sigma minus B, right? So sigma means whole space, this means whole space, whole probability space. So P of this means P of A intersection these minus P of A intersection PB. So this means P A intersection, it's since in the whole space A is there, so the intersection between A and whole space will be A. So P of A minus P of A intersection B, which is not equal to P of A P of B complement. So that means P A B complement are not independent, so this is not true. So A complement B, let's check similarly. P A complement B is P whole space minus A intersection B B minus P A. So this is also P of B minus P of A. So this is also not true, which is not PA complement into PB. So this is not true. That means this is not true, this is not true. So let's check 3, A and A complement. P of A intersection A complement P of A intersection of whole space minus A. So P of A intersection whole space minus of P of A intersection P of A. So that means P of A intersection, so this is P of A okay P of A, sorry, I think I am doing it wrong, so let me first P of A, so this is 0, so this is not equal to P of A into P of A intersection. So I think I am doing wrong everywhere here. So yeah, it is not true, since we know that P of A intersection B means P of A into PB. So that means this means P of A minus P of A into P of B, which is P of, if I take common P of A, that is 1 minus P of B, that is P of A into P of B complement. So this is independent, so this is independent, this is true. Again this also where this also similarly here also I am P of A intersection B means P of A into P of B. So that means if I take common P of B, 1 minus P of A, that is P of B, P of A intersection. So that means this is also true. Let's check C. We haven't checked C, right? Okay. Let's check C. So this is not true. So that means 4th is not true. This is not true. Let's check C. A complement B complement, P of A complement E intersection B complement. So P of minus A whole space minus B, P of means whole space minus A whole space minus P of whole space minus A intersection P. So this is P of and this minus P of A intersection whole space minus similarly P of whole space intersection of B minus plus P of A intersection B. Okay. So this is 1 because whole space intersection is whole space. So P of, sorry, let me write it here. P of intersection minus P of, this is A, this is B, and we know this is PA into PB since PA and B are independent, and this is 1, so 1 minus PA minus PB and plus PA PB. So let 1 minus PA minus take common of PB, that is 1 minus PA, so 1 minus of PA into 1 minus of PB. So that means P of A complement and probability of B complement. So that means this is also independent of each other. So that is also true. This is also independent. So that means our which one of the following is not a correct statement. So this is not a correct statement. A and AC are not independent. This is not a correct statement. So that's it. So let's move towards the next question. That is question number 7. That is question number 7. A diagnostic test for certain disease is 95% accurate. That is, if a person has the disease it will detect it with a probability of 0.95, and if and suppose that 0.5% of the population has this disease, Now question is, a person is chosen at random from this population The test indicate that these person has the disease. What is the probability that he does have the disease? So this is a very interesting problem, and this is a very interesting problem, and I think the outcome, the results will be surprised you, will be so surprised you, because let me calculate it. Diagnostic test for a certain disease is 95% accurate. So suppose the test is accurate how much? 95%. So if you do the test, how many what is the probability that it will be correct? That is 95%. And 0.95, probability is 0.95. Suppose that 0.05% of the population has this disease. So very few number of individuals have this disease in this population. Suppose now from that population, if you picked an individual randomly and do the test, and the test give you a positive result, right? That means now what is the probability that these results are true? That means the probability that he does have the disease. So we have to calculate. So first let me write, E denotes here a person has a disease, and what is the probability of that? So probability of that is nothing but, because in the population we already know that 0.5% individuals have that population, 0.5% individuals have that disease. So what is the probability? That is 0.5 by 100, and that is 0.005. Now F denotes test indicates a person has that disease. Okay, now what is problem? Some problem is always oh, what the so let me I think some problem is going on, so that's, let me reopen it. Okay, so problem is there. So PE is that person has the disease, so PE is 0.5 by 100, so that is 0.005. and F means test indicates that the person has the disease. Okay, now we know that the test indicates that this person, the person, suppose some individuals go to that do the test, and he get that test, which test is the test is actually 95% accurate. That means and he do the test and he get a positive result. That means he get that test is saying that the individuals has this disease. So what is the probability that that individual actually has the disease, given that he already has done the test and get a positive result. And you see that the test has a 95% accuracy. Now let me calculate that. So what is the probability when the test showing that individuals have the disease, what is the probability actually he has disease? So let use the Bayesian probability here, Bayesian theorem here, that means what is the probability that if he has the disease and do the test, what is the probability that the test will show that that individual has the disease? That is 95%. So we know that this probability. So here, since 95% accuracy, so we know that if that individual has the disease, the results, the test results will be positive. So that is 0.95 into probability E. How many of that population has the disease by the probability of F. With probability of F is nothing but probability of F E P E and probability of giving positive result. This is the individuals has the disease and getting positive results, but the individual does not have the disease but also get the positive results, and PEC. Okay, so we know all the things. P is 9.95 and P is 0.005 by PF is 0.95 into 0.005 plus what is the probability that he doesn't have the disease and showing positive result? That is actually 1 minus 0.95. So 1 minus 0.95 which is 0.05, and what is the probability that individual doesn't have that disease is 1 minus 0.005, that is 0.995, and you calculate this, you will get 0.08716. so you see that it is not nearly close to 1. Although the test has the accuracy of 0.95, probability 95, you will get that the actual probability that if a individuals get individual do the test and the test shows the result that he has the disease, but what is the probability actually he has the disease is very low, 0.08. so it's not nearly 1, but it's very lower than 1. So that's it. No, so that's the problem. Now let's move toward the next questions. So it is question number 8. Oh, sorry. Okay, it's question number 8. Yeah, question number 8. Okay. Which of the following is a valid probability mass function of a discrete random variable x on set 1 2 3 ... Okay, what are the options? A is P, X is X. What is the probability of, what is the mass function is Q X minus 1 P for 0 greater than Q less than 1 and p not equal to 1 minus q and x equal to 1 2, and b is px equal to x e to the power minus mu x to the mu to the power x by x factorial, and x equal to 1 2 3 dot dot dot, and mu greater than 0. C px equal to x 6 by pi square into 1 by x square. Here also x equal to 1 2 3 dot dot dot, and t equal to px equal to x 1 by x cube 1, all the positive integers numbers. So which is the following valid mass function, right? So what is the condition for the valid mass function? Let me write it here. Okay, conditions for valid mass functions. Yeah, there are two conditions that are valid mass function. The conditions, there are two conditions, there are two conditions which are which have to be satisfied for a valid mass function. One is p of x xi should be greater than 0, and 2 is summation of xi belongs to space p of x, that should be 1. So in the above all yeah, greater or equal to 0, right? Greater or equal to 0, yeah, greater or equal to 0. Thank you. Now you see that these a b c d all are greater or all are positive. So first condition already true, so let's check the second condition is true or not. So for question A, so summation of x equal to 1 to infinity q x minus 1 p, let what it be. So if you calculate it, so p summation of x equal to 1 to infinity q x minus 1, so this is p basically 1 plus q plus q square plus dot 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 will do, this is nothing but 1 minus q, so this is nothing but 1 minus q, so this is p by 1 minus q, which is not equal to 1. So that means the second condition is not satisfied, so this is not a mass function. Now let's move toward the option number B. So it is, let summation of x equal to 1 to infinity e to the power minus mu to the power x by x factorial, so e to the power minus mu summation of x equal to 1 to infinity mu to the power x by x factorial, so this is e to the power minus mu, so this is mu plus mu square by 2 factorial plus mu cube by 3 factorial plus dot dot dot. So we add plus 1 here and subtract 1 minus 1, so we know that this series is e to the power mu minus 1, so that is e to the power mu minus 1. So if you do it, you will get 1 minus e to the power minus mu, which is obviously not equal to 1, so this is also not a cumulative mass function. B is not true. Let's see. Summation of 6 by pi square 1 by x square x equal to 1 to infinity, so this is 6 by pi square, and so you know that these summations, that means 1 plus 1 by 2 square, 1 by 3 square plus 1 by 4 square, plus dot dot dot, this series value is pi square by 6, exactly pi square by 6. So this is 6 by pi square and pi square by 6, so this is 1. So that means, so these satisfied, these C satisfy size the condition for the mass function, so this is a mass function. And if you check the summation of 1 over x cube, you will see that it is not equal to 1 and it is not be a mass function. So that's it. Now let's move toward the next question. Question number 9. So let E and F and G be any three events with PE is 0.3, PF given E is 0.2, PG E given G is 0.1, and P of F intersection G given E is 0.05. Then we have to then calculate what is the value of P of E minus F union G. That's it. How to calculate it? So let's calculate it. So first calculate the value of P of E. So that is given, P of E is 0.3. Then now we can, okay, then what is the value of P of E intersection F? That is P of E into P of F, E given E. So that is given 0.2 and 0.3. So 0.3 into 0.2 is 0.6. And okay, and another thing is this is given. So let's calculate G intersection E. P, similarly G intersection E will be P G given E and PE. So this is 0.1 into 0.3. So this is, I think, 0.06. So 0.1 into 0.3 is 0.03. Another thing is given, P of F intersection G E given F intersection G. So from here we can calculate P of F E intersection G intersection F. That will be this, P of F intersection G given E into P of E, that is 0.05 into 0.3, that is 0.015. Now we have to calculate P of E minus F union G, which is P of E minus, okay, so to see it, let me draw a Venn diagram from where it will be cleared. Suppose that there is a E, there is a F, and this is G. Okay, suppose this is E, this is F, sorry, this is F, this is F, and this is G. Now we have to subtract from this green region to these blue and red regions. That means we have to subtract these two regions. So F union G, what is F union G? If this is F, what is G? Oh, this is G. This is G. Now we have to subtract these both region from E. Now you see, if I subtract PE, subtract PE, okay, right? PE minus PE, I'm sorry, if I subtract F union G, you see that the how many times I am okay, sorry, I'm getting it wrong. I'm giving so this is not true, so this will be what? Let's see what. So from PE we know that these all green regions is PE, so let me draw PE. These all the regions are PE. That means if from PE, if I subtract this part, that means minus PE intersection F, and also subtract this part, that means PE intersection G, I actually get that E minus F union G, because the only part that is inside E of F union G is these two parts, right? This part, and this part. That two part is only inside the E. So if I subtract these two, we'll get the PE minus F union G. But you will see that this small region where these three sets intersection, I subtracted two times, because for E, if I subtract E union F, E intersection F, I subtract 1, and when I subtract E of E intersection G, I subtract again. So this is in I subtracted two times, so we have to add is one time. So if I add one time, so this is E F G. So that means this will give me the PE minus F union G. So now you only have to put the values. PE is 0.3, E, and these two intersection 0.06 minus 0.06 minus 0.03, right? And we have to add 0.015. So if you do it, you will get 0.225. So that's it. Now let's move toward the next question. Yeah, question number 10. Okay, let's move toward the question number 10. Question number 10. What is the question number 10 is? Let x be a random variable defined on a probability space sigma f p, where sigma is the sample space, and f is a sigma algebra, and p is the probability measure on sigma f. Okay, suppose that f suppose that another function f, suppose function f is a map from R to R is a cumulative distribution function CDF. Then consider the following statements and which are the true or false. Statement 1 is F is always a monotone increasing function. Yes, it is. So this is true. Now second is F is always continuous on R. F is always strictly increasing and monotone increasing. Different between. I think both two are same. So let me check it. So hmm hmm okay. So actually I'm from physics background, so I currently I don't know, but I remember your questions. What is the difference? I am from physics, so I will read that things. What is the difference between monotone increasing and ha ha ha. Okay, okay. Reduced. Okay. Yeah. That's a question. Means for me, I think that monotone increasing means which increasing always, and strictly increasing means also same. Huh. Okay, strictly means only greater than. Ah, I get. I get your point. I get your point. No. I get your point now. So you are saying that monotone increasing because AP is a monotone increasing means it can be equal means only increasing. Yeah. I got. Yeah, I got your point. I got your point. I got your point. That probability CDF should be a monotone inclusive because suppose you see that suppose this type of function can be a CDF, right? So here you will see that this is not a monotonic increase strictly increasing like this. It's actually less or equal what you are suggesting. So you are right that it is a monotone. Uh-huh. Okay. Yeah. Thank you. Okay. Thank you. AP is so okay. AP is always yeah. Okay. Any no here I am only solved the week 2 assignment 2. Assignment 3 there is no related question in assignment 3. Assignment 3 I will solve in next class because you see that the question that are given in these assignments and the previous year solution are previous year questions are same, so that's why I'm solving the second. I mean, you have to solve the assignment 3 by your own self, so that's it. So yeah. So you can ask me any question from the assignment 3, but I am only solved the question from assignment 2 because you have to solve the assignment 3. Okay. Okay. So if is always a continuous on R. So AP is always a continuous on R, and 3 is so that CDF are not always continuous, so this is not the requirement for the CDF, and the AF is always right continuous. It is true, AF is always right continuous, that is uh, so CDF has to be a right continuous function, and so this is true. And the fourth is limit x tends to a, fx equal to fa minus probability of x equal to a. So let's check the fourth condition. So from schematically we can see these 4 actually true. So suppose suppose this is a this is 0, suppose this is a, so this is a CDF, and suppose this is x equal to a, and it is that x less than a, that means excluding xa, what is the limit x a minus means that the apex of the all excluding only xa from the left hand side, so from all region only excluding xa. So that means if I calculate the CDF, the all CDF from FA, that will include also XA. So if I want to calculate the limit that x tends to minus a, that means only excluding the point xa from the left hand side, so that means it is also true, that is fa minus probability of x minus a. If I subtract that, I will get this limit. So this 4 is also true, so that means that's why this 1, 2 and 4 is true here. So that's it, and this is the thing that I have for today. Next in the next class I will solve the assignment 3. So that's it. So if you have any questions, you can ask me, or I will exit this session. Okay, thank you. So thank you for joining. Yeah, so that's it. Then I am exiting this tutorial, this quitting this tutorial for today.